So this is a BOF 7007, in case you needed to know that. And my name is Harold Carr. So we're going to talk about remoting systems. And so let's start off with what is a remoting system? It's just something that allows you to call services or methods or procedures or functions on one machine onto another machine and without really having to do much extra. And you don't have to know anything about the other machine. And that's kind of the picture. So you got your client app code. It talks to a remoting system. And by remoting system, I mean DCE, Corba, RMI, RMI-IIOP, SOAP, on and on and on, which is what we'll get into, some of the details of those systems. And they're the ones that are responsible for doing the work for you and then sending on the network and doing the work on the other side and then calling the code. So what goes on with all those systems? Well, before we go there, I'll tell you a little bit about myself to kind of give you maybe confidence that I have some knowledge here. And I did at the University of Utah as part of my graduate a thing called DC++. This was in the late 80s, early 90s. We actually did a thing called Concurrent Utah Scheme, and then our funders wouldn't pay us to do Scheme anymore, and I volunteered to do C++. But anyway, it had lots of things in it, but the two things that it had was this DC gateway and DC value, which are basically turned out to be exactly what Java used about 4 or 5 years later for RMI, where they have remote and serializable. And then I also did a thing in the early 2000s when SOAP was coming along, because a lot of people in the companies I was working for building platforms say, we got to build this brand new SOAP platform. And I said, we can reuse our Corba stuff because it's all the same stuff. It's presentation, it's encoding, it's protocols, and it's transport, and some other things too. And I showed some architectures, and didn't do me any good. They still build it completely separate. But it did get me the SOAP job later. So I guess that did do me some career good, but technically it was like, well, maybe not. So, okay, so let's actually jump into what are the characteristics of a remoting system. And this is kind of the bigger picture. Usually you'll just see a picture that looks like that one. Remoting system, does everything for you, don't worry about it. So we're going to break that down a little bit further and show it. So the first thing is you've got your client-side app, and it's got to talk to something. And generally, in most remoting systems, you have some sort of objects or runtime system that you talk to. And so you have some sort of proxies or stubs. Has pretty much everybody used one of these systems, Corba, or who hasn't used a remoting system? Oh, one person. Okay, good. That means your life's been much easier. So you have these proxies and stubs, and they're what you are going to talk to, and that allows you to pretend like you're making a remote procedure call, and it tells you what data types you can actually send on the wire. Then, to actually get the data types on the wire, by wire I mean the network, you have to encode them some way. XML, CDR, XR, XDR, there's a million acronyms for it. And after you've encoded the data, your actual data, that's the important thing, you got to surround that data with some protocol information, like what message is this, what is this for, is this a request, a response, a fault, all that kind of stuff, metadata. And then finally, you write it out on a transport. And a lot of times people mix up protocol and transport. I think if you, not you as a user of a remoting system, but if the writer of a remoting system, if they're fiddling with bits in the, like HTTP header bits, then you're dealing with a protocol. Once you actually just grab something and send it on something, and you're not dealing with the bits, that's the transport. Like, how many of you have touched TCP frame parameters? Oh, right. See, you're really low level. Yeah, right. Yeah, it's a little harder from Java. So a transport is something where you just send it on the I/O string. You don't touch any header bits or anything like that. So then it goes across the wire, and it may or may not have support for things like attachments, etc. And then it does the opposite, basically, on the other side with one extra bit, which I'm calling a servant locator here. And the servant locator, we'll get into that, but it just means find the code that's going to run this finally for me. And then there's a lot of other pieces down below, from authentication to security to sessions to directory services to distributed garbage collection to activating a service, making sure it's still alive, that's what ping means, and to code mobility, so you can ship code somewhere if you don't need it, if you don't have it and you need to run it. Not necessarily all those things are a good thing. I'm just saying they exist. And that's kind of what I'm trying to show in this presentation is my view on the pieces that are probably useful in the long run and the ones that are not so useful. So, you know, it's been a long learning curve to do remoting right, and we actually haven't done it right yet, but I think we're closer. And I just said this, but it's in words, so I won't say it again. If you see the slides later, that helps. So here's my main point of the whole talk. There were RPC systems, and that includes DCE, DCOM, Corba, RMI, RMI-IIOP, and all that stuff. And they basically were simulating a single address machine. They had all sorts of stuff, like if the thing wasn't running, it would start it for you. It would make sure that it's kept running for you. And so you could pretend like it was just always there. And that was really not a good idea. It's very fragile. But people, that's where they started. Then, believe it or not, and this is something I kind of learned putting these slides together, SOAP actually did something good. Now, remember, I'm the SOAP architect at Oracle, so can't make fun of it too much. But no, SOAP's a great thing. It is. He laughs, he doesn't believe me. But anyway, SOAP did something in terms of the specifications. It really concentrated on the wire protocols first, and it would left it up to everybody else, like figure out how you get stuff on and off the wire. But this is what it looks like on the wire, and that's really the important thing, is what's on the wire. And so that was a good thing. Unfortunately, there's some RPC bits still in there, and I'll go into more details on that. So then the next thing is actually REST took it actually another step further and in a good direction. And that says not only do you just think about the wire, but you don't want to think about it in terms of RPC at all. You just want to have this message that you sent, this document you send across, and that's what you deal with, is a document. And that turns out to be actually a better model for a lot of things. If you're writing embedded controllers, that's probably not the model for you. RMIs or something like that's better. But if you're doing a document exchange, this is the one. So there's still, you know, when I have certain judgments, but there's also, they have to be colored with use cases. And then there's WebSockets, which seems to be the latest, greatest thing. And it's just TCP. That's all WebSockets is. And so don't reinvent everything the above. And you should use it for real-time events, and that's it. If you start reinventing everything above, you're writing a lot of code that you probably just don't need to. So I'll go into that. So this all comes down to these things called the 8 fallacies of distributed computing, which some guys, I think it was in the 80s, Peter Deutsch and some others at Sun Microsystems put out. So they said, you know, the network is reliable. Well, that's a fallacy. We know it's not reliable. Latency is 0, bandwidth is infinite, all these things, it's just not true. What's kind of funny is then Sun did ONC anyway, which was their network computing, which basically made it look like you were doing a procedure call on the same machine. So I think they broke all the fallacies, even though they at least recognized they were fallacies. Okay, so let's dive into the first one. I'm going to talk about DCE. And DCE was started in the early 1900s by a consortium of people that hated Sun. Literally, Sun had done, this Unix 5, S5R4, right? And they wouldn't license it and stuff, so everybody said, well, and we'll do this DCE thing and we'll make it so our computers can talk to each other and all these great things and we won't need you at all. So they did. And their function of the DCE is so you can authenticate users and then call resources or methods on other machines. So this is what the typical slide they put out for DCE, the architecture. This shows that they're trying to make it a single machine because they have distributed file service. So you can pretend like when you access a file, it's right there, even if it's, who knows where. And that's maybe a good thing, maybe not a good thing. I think in most cases, it's not a good thing. They have directory services, so you can look things up. There's already DNS. Do you need another layer on top of that? Well, maybe you do. There's a time service. The time service is so you can actually pretend like it's one big computer, all the computers network together, and say if this message, arrives 5 milliseconds late, well then forget it. You should just assume messages are going to arrive late and write your code so it can handle those things, not build in a time service. Management, the whole management thing. You actually needed a manager to put together your whole system. Rather than just writing a web service and calling it or putting it up and letting people use it. There's threads, so if they had their own portable threading model. So there was all that stuff where really we're going to focus on today is RPC. They also, and security. They did security and they did security really well. So let's see, I said the origin, oops, the wrong direction. That's another slide of the same thing. This slide kind of makes it look like it's all on one machine, and that's kind of the point of their architecture. But it's really on a network, so you have, really the file server might be somewhere else, the administrator somewhere else, the time server, it's a security server. Okay, whoops, that was not supposed to happen. Okay, so the first thing at the top of that one slide of characteristics of remoting systems was description. And, I actually didn't mention that, but so idle or WSDL, or waddle, or wiggle, or any of those things. And this is what a DCE description looks like. And I won't go into any detail, but you can see it's got a little bit more generally than what you'll see in, actually, WSDL's got this beat in terms of verbosity. But, so it basically it's recording, the hello world function, greet. And this is how you call it. Simple, huh? Aren't you glad you don't have to write this code anymore? Of course, maybe you do. You still write C code?
No.
Oh, okay.
Last time, 1999.
Oh, okay. Yep. Well, you're off the hook. So this was all so you could write hello world back and forth, echo. So it wasn't particularly easy. The next thing was your data types. And this is just shows you that, in your idle, if you said something was a Boolean, NDR is their encoding type, so it's called a Boolean, and then you use in your C code a thing called idle underscore Boolean, and what it translates into in C is an unsigned char, and a whole bunch of other things. And what they did with that encoding is map it very specifically to the bits, so you knew. And actually, in some respects, that's a good thing, in some respects, it's a bad thing. Now everybody uses JSON now, or XSD. JSON is just like, you got a string, and if it overflows on the machine that you're receiving it on compared to the one you're sitting on, well, that's your tough luck. You go figure it out. With XSD, at least it really does say what the type is, and you've got to translate it right. With this, it also says very specifically what it is, and that's both a good thing and a bad thing. Good in that if you're writing scientific computations in a distributed network, you probably want that. You don't want to lose any information. If you're doing a web app, a mobile app, you probably couldn't care less. Well, unless you really deducted a lot from your bank account, then, but I don't think that's it. So, okay, then the protocol. That was the bit, you know, all the surrounding bits. Well, I won't go into this, but this is what's going on in the DC header. And it's pretty frightening. But of course, the only reason it's not frightening when you see SOAP is because it's a little bit easier to read, but not much. Okay, and they have 1 million transports, DCE, so that's good. You know, you can send it on TCP, UDP, and a bunch of others. I'm going to run through these. Now, here's the thing that I said that DCE got the best. It was security. It's still a high point in distributed computing. And they had, so you could authenticate users with a third-party service that did the authentication for you, and then would say, give me a privilege so I can talk to a particular computer, and then the computer can do access control lists and that. They also had pluggable security, so you could do it a different way if you really wanted to. It was all based on Kerberos. And I still say that is actually one of the best efforts of security in distributed computing, and it was the first. It wasn't really the first, but it was really the first more widespread one. So here's the summary of, whoops, what happened? I'm missing a slide. Okay, well, I'll use this one. So for the summary for DC is, you know, they use IDLE for description. They have a compiler that takes IDLE to C code, or I think C is the only one that I actually know that DC worked with. Maybe they had other language mapping, C++ or whatever, but I'm not sure. Then they had the data types you could send were basically what you could describe in C. They encoded it in a binary type, which unfortunately, if you want adoption, you really don't want to define a binary protocol. It's pretty much proven by experience that for adoption, you want a human-readable protocol. I mean, email was really successful way before HTTP was around, and it was a human-readable protocol. And HTTP was very smart because it did the same thing. Their transport is good because it has a lot of them. Security is great in DCE. It's still a high point. Sessions, I'm not sure if they had any sort... Oh, don't do that to me. Hey, is there a technical guy here? The tech guy? That quit working. You know, did something similar to me last night. I think this thing just completely died. Well, while we wait for the tech guy, I'll get my computer out and see if it does any better. I worked really hard on these slides. I'm going to be pissed. Okay, let's see if I get lucky. Kinda. Now I got to get it over there so it actually works. Oh, this guy. Displays. Now usually I just say detect displays and then it magically grabs them together. But I thought it was detect display. Isn't that what it is? Or okay, let's see if I can scoot this over. So okay, I'm gonna fake it. I do not know why this thing, oh man, I lost it. Where is it? Show windows. Man, this is really sucks. God. Okay, you know what? Can you read it? Because I can't see it on my screen and I can't get to it any longer, so I don't know what's going on. Oh, good. Let's see what happens. Oh, it doesn't work so well. Okay, so let's just do this. Sorry about this, but and I can't figure out why this is not grabbing the right display. And I can't even see what you're seeing. I can't even see, and I can't get to it any longer. You know what? I think I'm going to give up and just do this. Okay, let's get to where I was. So I really can't control this because I can't get back to that window. It's bizarre. Oops. Okay. Oops. Whoa. Whoa. Okay. Okay. I'm just going to go with what I got. Can you read that okay? Yeah. Sorry for that technical glitch. Anyway, so where was I? Oh yeah, so anyway, it's got lots of stuff. And let's go on, because I just lost some time. So Sun also had to do its own DCE-like thing called ONC. And now I hate reading to the slides, but I can't see them, so I don't know what I'm talking about. But you can see it wasn't actually as good as DCE. So the next thing comes along is DCOM. And basically what Microsoft did is they tried to license DCE from the open group, and they had a charter which made it way too expensive for Microsoft. So they said, forget it, and they basically re-implemented it from scratch. Isn't that what they did with DOS too? I guess they're pretty good at that. Anyway, the main thing they did too, besides re-implementing it, then they added DCE was remote procedure call. So what they did was, instead of making it RPC, they made it object-oriented. So it was OOP. And of course, you know, if you think about the time period, DCE was kind of before object-oriented computing really got going as a hot thing. And then DCOM, by then, it was the hot thing. So they had to do objects. So they did that. They also did distributed garbage collection. And that gets back to that one characteristics of distributed systems, which I say in general for most apps being written today is a mistake. You don't want to be, the remoting system, you don't want it to be simulating a single address machine. And so by doing distributed garbage collection, when somebody's, you know, when you've let go of the reference and they do counting and all this stuff, then great, it'll clean up your object for you. And that's way too fragile, and you know you're going to have problems if you do that. So here's something we're going to deep dive in. No, that's just to show you DCOM. And you'll see later when we get to some of the other systems, they look a little simpler. So we won't go into the nitty-gritty of this, but it has all sorts of fun stuff going on. And that's things like activation. So if the service isn't running, it'll start it up for you. If the service is, you know, make sure it stays alive. Even so, if it dies with sending these pings, it can actually get it going again before you even want it. All sorts of cool things. But it's really more than most things need. Okay, so now we're going to move on to Corba. Corba also came along about the same time as DCOM and said, well, that DCE stuff, that's no good. That's procedure calls, and everybody knows procedure calls aren't cool. Objects are cool. So we've got to do the same thing in object-oriented style. So the first thing they did was define all this stuff in Corba 1 in object-oriented style, but notice that bold where it says no wire format. Corba actually defined a whole bunch of specs, and they had no wire format defined. So, and it took them till Corba 2.0, 1996, before they actually like, oh yeah, I guess we want to talk to each other. So they figured out they better do a protocol. So they did this GIOP, which is kind of an abstract protocol, and then it could map to specific ones, and the two main specific ones are IOP, meaning the one that goes on the internet, and then a DCE one that existed because you wanted to interop with DCE also. And there's a lot of other things they defined, like particularly a lot of language mappings for Java, for Ada, for Smalltalk, for C, for a million languages. And that's both a good thing and a bad thing. Okay, so there's a lot more history here. And the ones that were, oh yeah, so there's a couple of them in bold: portable object adapter, portable interceptors, and object reference template. I won't describe those, but I had the good fortune to be involved in those. The definition of those things. Meaning, as a friend told me once, friends don't let friends do standards. Take that advice if you're ever invited to join a standards team. And so here's the Corba architecture. And the main thing that I want you to see on this one is the very top thing where it says inarg. There's the operation. It has inargs, and then it has return value and outargs. That's another mistake because it's trying to simulate single machine things. So when you have pass by reference, that's an outarg. You know, you put it in there, you give a reference, and you get it back. Come on, really. Just send the data and give it back. You don't have to pretend like it's, you know, pass by reference and all this. But that's because that's the mindset. You know, it's easy to make fun of it now. But the fact is, it's really hard. When you're in a particular time, you're in the mindset of that time. And to do something different than that mindset is difficult. So even though I'm kind of making jokes about this, I made all these mistakes. I'm laughing at myself. So, and this is kind of another picture of the same thing we've been looking at. You know, you've got the client, and it can talk to stubs, which are what they're called on the client side, or you can talk to this dynamic interface. I better speed up. And dynamic invocation interface just means instead of having compiled stubs, you can just dynamically decide what you're going to send. Hopefully it's going to match what the server wants. But those things are kind of good for if you want to build intermediaries. And then the orb interface. Okay, so let's go on. So here's the good of Corba. Here's the bad. Let's start with the bad. So OrbD, that's another one of those activation things. So if it's not running, it'll get it running for you. It's objects. Well, objects pretty much by definition have state. And I think that's another thing we've learned over time is don't put server-side state in your distributed system. So, and it's also, it's not leveraging the internet protocols. And to be fair, they were, quote, kind of new. HTTP was certainly new about the same time as Corba. So, and a good thing is the language mappings, because like I said, if you need precision, you really need to know what's on the wire, what it turns into in your language, the data. If you need precision. Notice that's in the, I'm getting ahead. That's on the bad column, but notice it's also in the good column. It's bad because that's a lot of work to do a language mapping. And a lot of, probably for, who knows, 80, 90% apps, it's just really not that necessary in terms of the data. So the good part of Corba is the service description, the IDLE. Descriptions turned out to be useful. The strong typing, atomic transactions, POA. POA means portable object adapter. That's the thing that's going to find the code that actually, on the service side, that's going to run your service code. And the POA gives you a whole bunch of ways to do that, from using the same object for everybody or lazily start loading them, a million different ways. And it turns out telcos love that particular feature. They use that quite a bit. And the language mapping, okay. So there's the Corba summary. The main thing it didn't have was the distributed garbage collection and the code mobility. Okay, so I think we said that. Let's go on. Okay, so RMI pretty much was a Java-only version of Corba or DCOM or any of that. It's object-oriented. You could do it in Java at the top, and what you could send across on the wire were the basic types or any object that derived from serializable. But you had to sometimes help the serializer a little bit And the encoding was no standard, but they called it JRMP. Although I don't even know if that was actually an official acronym, but that's what it's kind of there. And it went on TCP. If you needed security, you used SSL, but nothing more than that. And same thing for authentication. You could do SSL with client auth. It had a registry. It does have code mobility, which at one time that seemed like a good idea. I'm not so sure anymore. Genie actually took advantage of that quite a bit. Genie was is kind of a core RMI++. And it was, you could actually, using any protocol, even just a raw TCP connection, say, you know, I want to talk to you, and it would download the stubs that would know how to talk whatever protocol it would with Java stubs, and then it would do this. So it really relied on code mobility a lot. But Genie didn't really succeed, that's for sure. Okay. Okay, so then Corba came along, the OMG came along again and says, oh man, just as we were getting everybody to really pay attention to us, then Java comes and says, oh, here's this better thing, and everybody loves Java. It's so much easier to code in, which is true just from garbage collection alone, automatic garbage collection. But when they added the RMI thing, oh man, how do we get the people to come back to us? So they did RMI-IOP. And what that meant is you could program in the RMI programming model. And what that is you just say, you know, you inherit from remote object. And instead, you just inherit from a different object, and suddenly it's RMI-IOP, and it talks IOP, uses the Corba data representations and all that stuff. So it seemed like a great solution. Does anybody use RMI-IOP? You said you didn't do it. Oh, okay, cool. Why? It was there, right? It's kind of like Mount Everest, right? No, I mean, I'm joking, but we use what we use at a time because it's in front of you sometimes. We need to use it. It gets the job done, use it. And you find out later, like, oh, shoot, there was a better tool, but we shipped, it's too late. No one's ever done that, right? So, but anyway, so they said, okay, we're going to make this RMI-IOP thing. Suddenly we'll get everybody to come back to Corba. And it turned out to be a little confusing to people because, wait a minute, you already had Corba in Java. It was this thing that mapped IDLE, the Corba objects, to Java objects. But now you're saying you've got this other thing called RMI-IOP, which is really Java to IDLE. So you could write in Java to begin with, and it would translate into Corba. I mean, you would write in Java to begin with, and it would translate to Corba IDLE. So other people then on Corba could reach into your Java objects that way. But basically so you could write in Java only and not have to think about it. Interesting idea. I've definitely worked on a few bugs in that system. It does have some hidden consequences, and that one there, that hidden orb, that one is a killer. Because when you're sending data, particularly objects by value, and when you send it to the other side and they don't have that code, it's got to get the code. And to get the code, it's got to talk to the orb. But the orb doesn't exist in RMI-IOP. In regular Corba programming, you actually have to deal with the orb. The orb's basically the interface that you talk to set up all the remoting stuff. And the orb is invisible in RMI-IOP. But there has to be one. Oh, no. No, no, no. No. Don't do that again. Oh, good. So, and also, not every Corba object can translate to Java to IDLE. So that one's, I'm not so sure if I'd use that one. But at least it didn't have distributed garbage collection. Okay, let's move on. SOAP. Okay, now we're getting to something I actually work with now. And this is actually part of my main point. See, everything we've talked to up till now has really been this single machine simulation, more or less. I mean, that's a broad categorization, and every time you broad one, you've got to have caveats left and right. But still, There's a lot of stuff that's trying to pretend like it's single machine. With SOAP was the first system that really did, it says here, remoting system. Email is not a remoting system, but it's the first system that says, here are the wire specs. Go build your systems. And that's a good thing, because it actually got away that there's no activation, there's no objects, even though the name of it was originally Simple Object Access Protocol. Of course, they decided later it wasn't object SOAP, it's just SOAP, and it's not an acronym anymore. Actually, let me tell you another story about SOAP. It actually, the real reason SOAP exists is because Java in the late 90s was just eating Microsoft's lunch. And they were going, what do we do, man? What do we do? We got to get these people back. Oh, wait a minute. What else is hot? XML was really hot in the late 90s, early 2000s. So he says, I know. Let's turn XML into a remote protocol, and then you don't have to have Java on the other side, and everybody will come back and start using Microsoft again. And then they marketed it really well, because it really went. So anyway, that's my take. I don't know if that's true, but I think there's something to that. So, but SOAP, be that as it may, it actually is a good thing in terms of the evolution of remoting systems, because it really focuses on the wire. There's no objects to be seen. There's no directory to be seen. Sure, there was this thing called UDDI, but nobody uses it. There's no activation ping. There's no distributed garbage collection. There's no code mobility. All that other stuff, because what you got is you've got some service out there in the network. You don't have no control over it. All you can do is send it a message, and hopefully you'll get something back. And if you don't, you better have code to deal with the fact that it's not responding. And that is the way you have to do distributed computing. If you try to make the infrastructure to take care of all of that for you, it's too fragile. It doesn't work. So anyway, SOAP was a good thing, and is a good thing. Except it still has the RPC pedigree, and that's this mindset. And that is, if you look at it, it has these things called RPC encoding, RPC literal, doc literal encoding. And the RPC in RPC literal is just what it says. The RPC makes it so you can make procedure calls, but you really don't want to do procedure calls. You want to send documents. So RPC lit says, oh, well, if you put one parameter to your call, to your method, and it's an XML document, then we don't have to serialize it because you've already done it for us. And then doc literal takes that another step further. So there's still, some cruft in there. And also WSDL ports inside of WSDL, they're kind of essentially objects, and the operations are the methods. Or, if you want to be, it's RPC, it's a function library with a bunch of functions. So it still has some of that stuff left. And also in frameworks that you use, like JAX-WS in Java or .NET, you put an annotation on an object, and then it turns it into a service for you. And that's easy, and it's useful, but it's also RPC, and there's nothing wrong with it in the right place. But I'm just, in terms of the kind of, this picture I'm painting, leaving MarkVC, getting towards wire protocol, and finally, when we get to REST, you'll see the next part. Don't want to give it away yet. There is in JAX RPC, to be fair, some interfaces that called dispatch and provider that allow you to actually work at the XML level. So you can deal with the payload and you don't have to think about the other stuff. But they're hard to use. Now, for SOAP, the main use case is security. To me nowadays, the main reason to use SOAP is security. And what it does really well, and REST can't touch it, and Corba can't touch it. DCE can touch it, but you don't want to use DCE. And that is, it has this thing called WS Trust. It makes so you can write security token services. And what a security token service is a third party, either you wrote it or you can offload it to somebody else, that is going to authenticate your users. You really don't want to have every one of your services that you write have to have the authentication built in. You really want that to be decoupled from your actual service that's doing the work. So to allow that, SOAP has this thing called WS Trust that defines a protocol, so the client, when it tries to talk to a service, under the covers, it'll actually start talking to the STS to say, I need to talk to that service, give me a security token so I can do that. Now, you don't have to write that code. All your code does is a regular remote method call, but under the covers, it's doing this handshake with the STS to get this token. Once it has that token, then it uses that and some other stuff to build public-private keys, and it does encryption and signing on the wire using WS security, and that's end-to-end security. So even if it goes through a router or 10 routers or load balancers or anything like that, the data is still encrypted. Nobody sees it until it gets to the very final destination, and that's where it's decrypted. And that's a good thing. For if you're writing banking software, if you're writing medical software that's sending images back and forth of your patients, that kind of stuff, you really want this kind of end-to-end security. And you want the strong identity. So that's the main use case for SOAP, and it actually does it really well with the caveat, and it's interoperable, with the caveat that you really need to stick with well-known security types, like mutual authentication and stuff. Because the minute you try to configure it somewhat odd, it's almost impossible to configure .NET and any Java-based system to do that. It's possible. You'd spend months doing it. So you need to stick with pretty much well-known security regimes. Okay, so here's the SOAP summary. So you've got any language at the top. You've got C, C++, anything. Pretty much everybody does SOAP. And then if you're using a framework, then you've got something like JAX-B that is doing your data encoding for you. Or you might just be sending direct XML documents. When it actually goes on the wire, it might be just XML. It might go into some binary encoding like fast info set. And for protocols, there's HTTP, which is a standard. SOAP over JMS is a standard. There's also some non-standard things for TCP and WebSockets. And they also have support for attachments. Notice on all the other slides, you probably didn't notice, but if you look back, it didn't say attachments. There was no concept of attachments, but it actually is leveraging attachments. And the things that it's leaving out are the directory, the distributed garbage collection, the code mobility, the activation ping, and I claim those are good things to leave out. It also doesn't have a servant locator, and that is usually okay too. Although if you're using, well, I won't get into it. Nope, that's extra. So, okay, now let's go on to, that's the same thing in words. Okay, the next one. Okay, so I'm saying that REST is the second and larger divergence from RPC. And that is, it focuses on the data exchange, and it doesn't even define any wire protocols, right? SOAP really is a protocol. REST is not a protocol. It's already there. It's just using HTTP. It's using email MIME types. It uses DNS. You give a URL, and it's DNS that you look things up with. I mean, there's no SOAP specifications. It's just leveraging what's already there. And that's a good thing, as you'll hear from a million REST guys, because if you send, a GET and you end up at an intermediary that's seen that same GET, he can send you a cache copy and rather going all the way to the service. And that's a good thing. You can't do that with SOAP. There's no description with REST. There's a thing called WADL, but it's not widely used. There's no objects, there's no directory, no activation, no ping, no distributed garbage collection, no code mobility. All that is good not to have. Except for the description, I think the description could be useful. And I think that's a whole. What people do when they write roast programs is they go to the website that you want to use them as a service, and you go to the thing and you read their description as a human, and then you hopefully do what it says, and that's it. I think it really could use a description language. So here's the REST picture. And for security, all you get with SOAP is SSL. If you wanted to do something, like I said, the big use case for SOAP is end-to-end security. If you wanted to do end-to-end security with REST, you would have to do it at the application level. The framework can't do it for you because it's just talking to REST, and you're actually in charge completely of what goes into the body of the HTTP message. And there's no REST spec to get in the way to do something for you. So if you want it encrypted, you've got to encrypt it in your application level, and same thing on the other side. And I think, there's a little bit of stuff in OAuth. I know OAuth was originally a thing, so you could give out credentials to third parties for a moment so they could look at your contact list or something. But I hear there's some stuff about actually using it as some sort of authentication thing for REST, but I don't know a lot of details about it. So there's the REST summary. Okay, let's move on. WebSockets. Whoops, I didn't mean to show that part. You didn't read that, did you? I already said it, though. So what is WebSockets? Did anybody come to my talk yesterday? All right, a few. Okay, well, then you already know the punchline. Check this out. I think that's the best description of WebSockets. People are a little... It's a new thing. Say, well, wait a minute. Well, I've been told I should use REST instead of SOAP, and I was told I should use SOAP instead of Corba, and I was told I was supposed to use RMI instead of Corba. Now what's WebSockets? Well, here's WebSockets. Look, the client just talks to the transport. There's nobody doing encoding for you. There's nobody doing protocols for you. There's nobody doing anything for you. You talk directly to the transport. There's nobody doing authentication. There's nobody doing security. There's nobody doing sessions. There's nobody doing anything for you. That's what I mean by WebSockets are just TCP. The way WebSockets works is, the use case for WebSockets is to replace ad hoc things like AJAX and things that have gone under the name like Comet, long polling HTTP streaming. And that is where your client is trying to pretend like it's a desktop app, and it needs to, when the server, something happens to the server, it's just got to show up. Well, you can't do that with HTTP because it's a request response protocol. Whereas with like Comet, what it does is you do a connection, and then the server holds on to it instead of sending a response right away. And then later, when an event happens, it sends the response, and that's the event, the real-time event. So it's just faking things. Or it might keep a stream open and keep sending multiple events down that stream. And so there's another thing besides WebSockets in HTML5 called server-sent events. And all server-sent events do is standardize Comet. But besides that, it also has WebSockets. And what that allows you to do is WebSockets, if you think about HTTP, a lot of people get this confused. HTTP is still just TCP. It opens up a TCP connection, and on top of it is the HTTP protocol running through that transport. And that's it. And with WebSockets, what happens is the first message you send on the TCP connection, the first HTTP message you send, is this thing that says, I want to upgrade to WebSockets. And so if the server that receives that can handle WebSockets, it'll send back the thing that says, yeah, I can handle that. And then they do some other magic, and what happens is then you have access to the already existing TCP input-output streams that were already there. There's no magic. HTTP was running on TCP. It just suddenly allows you to actually get now at the TCP streams, and that connection stays open because it doesn't get closed by the HTTP protocol because you're not running that protocol. So at that point, you have a transport. You don't have a protocol. You have the server. Yeah, the server.
No, the client, I would say, because you actually open a socket in the client, right? The server communicates with that socket, right?
Right. Yeah, that's exactly the point. Now you've got this thing where you've got these connections that stay open. It's really not a problem on the client. It's a problem on the server side because now your server has to do connection management. With HTTP, it comes in, it goes out, the connection goes away. By definition, there's no connection management. With WebSockets, Suddenly the server's going to have to say, oh man, I've got 10,000 open connections and I can't handle it anymore. So what do I do? Well, then you do these reaping strategies like, okay, which one's the least recently used and all that kind of stuff. And right. Well, what happens underneath the covers is who's ever writing the WebSocket client implementation needs to detect that went away and then reestablish it. So I don't know how WebSockets is going to really work out in practice with the connection management. Because if you want to, if somebody gets rid of your connection, but the client really does want to keep getting events, even if event hasn't happened for 2 days, it'll try to reestablish the connection. So it'll be this ongoing fight. So for today, my main point is WebSockets is just TCP. It's not a remoting system. It's just a transport. And it could be useful for events, but I'm really not still sure how this is going to work out in practice because of connection management. So that's WebSockets. Oh, I'm actually over now. So here's WebSockets, right? What does it have? Nothing. It's got transport, TCP, and it's got coupling, super tight. Because whatever you send on the wire, the only person that's going to see it and understand it is yourself. So that's really tight coupling. Okay, so here is the summary. RPC is basically trying to simulate the RPC systems as they were done, like the DCOM and et cetera, were trying to simulate single address machines. That's too fragile. The wire things like SOAP were better because they got rid of that part, but SOAP kept some of the RPC things, which makes it not as useful. Well, I shouldn't say not as useful. It's just harder to use than it needs to be in some respects. But the security built into SOAP's great. The document thing of REST is fantastic, but you don't get the same end in security. And WebSockets, it's just a transport. It's nothing else. You're on your own, 100%. And I'll just leave you with this. So there is on the drawing board the next big thing. And I'm going to talk about it next year at Java 1 if I get accepted. And but I'll give you a sneak peek. So make sure you all put on your surveys, you know, like you want me back, so they make sure they. And then if you do that, then this is what I'm going to talk about. That's the next best thing. I'm going to tell you how that works. And that's it. Thank you.
Looks like the flux capacitor.
Yeah, right.